Hello students, today we will be starting a new chapter called Linear Equations. Now the name should be familiar to you because you have been studying this topic since actually class 7 but realistically class 8. And this is the chapter where we deal with equations which have two variables. This year we'll be dealing with two variables. So an example of a linear equation is something like this: 3x plus 5y plus 2 is equal to 0. Now what we know so far from what we've studied is that you can graph this. If I have two equations, let's say I introduce another equation and I graph both of them, they will intersect at some point. Most likely there are some conditions in which they don't. We will look into those, but let's say they intersect. That intersection point is known as the solution of the equations. Now this year we will study many different techniques of solving linear equations in two variables and looking at some interesting word problems where it might not be very direct to you as to how to form the equation, or even if you form it, how do you solve it. So we'll look at how linear equations can be applied in clever ways to tackle this situation. Now before we move on to solving methods, let's study the concept of, like I said, will the lines intersect, will they not intersect, or what is the situation? So we have three scenarios. Let's say that my two linear equations are ax or a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So these are two linear equations. X and y are our variables. a1, b1, a2, b2 are coefficients, and c1 and c2 are constants. So like if we take this example, 3 is a1, 5 is b1, 2 is c1, 2 is a2, minus 1 is b2 because this can be thought of as minus 1 into y, and minus 3 is c2. Just by analyzing the relationship between these coefficients and constants, we can determine if we will have a solution, that is whether the lines are intersecting. If we will have no solution, that is the lines are not intersecting, which means they are parallel. We know from geometry that only parallel lines never intersect. Or if we have infinite solutions, which just means the lines are exactly the same. So the three conditions we have are: first condition is if the ratio of the coefficients of x and y are not equal. So a1 upon a2 is not equal to b1 upon b2. This means there is a unique solution, or that they intersect, that the lines intersect at one point. So in this case, we can see 3 upon 2 is not equal to 5 upon negative 1. That's why these lines intersect and have one solution. Case number 2 is where the ratio of the coefficients is equal. So a1 upon a2 is equal to b1 upon b2, but it is not equal to the ratio of the constants. In this situation, the lines are said to be parallel and we say there is no solution, or parallel lines. Finally, we have the case where all three ratios are equal. In this situation, they are actually nothing but the same line, because technically you can multiply or divide any line by any number and it will remain the same. So in this situation, we say that there are infinite solutions and that the lines themselves are concurrent. These are our three situations. So just by looking at our equations, we can immediately tell at the very least, will I have a solution? Will it be a single solution or infinite solutions? Or will there be no solution? So we will just keep this in mind when we tackle questions. But most of the time when you're given a solving question, it will be the first case, because these cases there'll be nothing for you to do once you've done it. These come as 1 markers and 2 markers that show that these lines are parallel. So we'll look at 1 or 2 questions based on that, but it's not a very big topic. Let's now get into actually solving linear equations. Let's actually very quickly look at a sample question on coefficients of the linear equations. So normally the question that comes will be something like this. Find the value of k if kx minus 2y plus 3 equal to 0 and 3x minus 4y plus 2 equal to 0 are parallel. They'll either say that they are parallel or they'll say no solution. So what we have to do in our mind is think, what was the case for parallel or no solution? That a1 upon a2 should be equal to b1 upon b2 and it should not be equal to c1 upon c2. So a1 upon a2 is nothing but k upon 3. b1 upon b2 is nothing but minus 2 upon minus 4. And we will just confirm that it is indeed not equal to c1 upon c2, which is quite clear because minus 2 upon minus 4 will just become 2 upon 4, which is half, and half is obviously not equal to 3 by 2. So this gets confirmed. So we will simply solve this problem. So we'll end up getting that k upon 3 is equal to 1 upon 2, which means that k is equal to 3 by 2. So we can say that k equal to 3 by 2 is the situation in which these two linear equations are parallel or have no solution. If the question said find the value of k such that they have a unique solution, then the condition would change to being a1 upon a2 is not equal to b1 upon b2. So actually when you would solve the question, in that your answer would come out to be that k should not be 3 by 2, can be any other value other than 3 by 2. So like this, all you need to do is plug it into your situation and then cross multiply and solve whatever situation you get. So comes as 1 markers or 2 markers, not a very heavy concept and a fairly easy and approachable topic. Now let's move into solving of linear equations. So there are 3 methods to solve a linear equation. The first method is known as the substitution method. Conceptually, this is the easiest method to understand. What we will do is, using one of our 2 equations, we will, let's say from the second equation, get the value of one of our variables, let's say in this case y, in terms of the other variable. In other words, what I am saying is, by manipulating 2x minus y equal to 5, by taking y to this side and 5 to this side, we'll end up getting that 2x minus 5 is equal to y. Now, what we're going to do is, this value of y, we are going to plug into the other equation, because the purpose behind that is then in the other equation y will go away, we will be left with just x and numbers, so we can solve for x get the value of x, then come back here and get the value of y. So what will happen when we, if I call this 3, put 3 in 1, this is how we symbolize it. The equation will become 3x, because x is not changing, plus 2 times y, and y is itself 2x minus 5 is equal to 6. This also will not change. So I will now solve this linear equation in one variable, which we've been doing since class 8. So 3x plus 4x minus 10 is equal to 6. This means 7x is equal to 16, which means x is 16 divided by 7. And this is nothing to be concerned about. X can be a fraction, decimal, negative number, whatever it can be. So we end up getting that x is 16 upon 7. Now I can come here, put the value of x into my equation 3, which will directly give me my y value. So by putting x equal to 16 by 7 into this equation, we'll get 2 multiplied by 16 by 7 minus 5 is the value of y. This is nothing but 32 upon 7 minus 5 equal to y, which implies LCM is 7. 32 minus 35 upon 7 is the value of y, or y comes out to be nothing but negative 3 upon 7. And in this way, we have solved the linear equation. We have got our value of x, and then from our value of x, we got the value of y. So this is known as the substitution method, because we are substituting one variable for another. This is conceptually the easiest method. It will always work. There will never be any problem in it. But as we can see, sometimes the calculations can be a little bit time consuming. So let's see another method that might help us fix this problem. The second method is known as the elimination method. Now in this, our goal is simple. We're going to look at our two equations and we're going to try to make the coefficients of either x or y to be the same numerical value, meaning by multiplication. So I can either multiply my first equation by 2 and my second equation by 3, in which case this would become 6x, this would become 6x. Or in this particular case, I can instead multiply my second equation by 2, in which case this would become minus 2y and this would remain as 2y. So that is exactly what we're going to do. We're going to multiply our second equation by 2. This would result in a situation where the first equation does not change, it is still just this. But the second equation becomes 4x minus 2y is equal to 10. We multiply throughout by 2. And the purpose behind this is now, since this is plus 2y and this is minus 2y, I can add my two equations to eliminate the y. If it was plus 2y and plus 2y, then I would subtract to eliminate the y. So here, by adding, I end up getting 3x plus 4x is 7x. Of course, the purpose of this was to make it 0 is equal to 16. And this will give us again that x is nothing but 16 divided by 7. Same as the previous method. Now that I've got the value of x, I will plug it into any one of my two equations and solve it. So let's say I plug it into my second equation. I'll get 2 multiplied by 16 upon 7 minus y is equal to 5. If you shift this, you'll end up getting 32 upon 7 minus 5 is equal to y. This is exactly the same as the previous method. So when you solve this, you end up getting y is minus 3 upon 7. So as you can see in this method, it's faster because the moment you do this multiplication, you add, you get rid of it automatically and you get one variable. B, the calculations are a little bit easier. The problem in this method is if your coefficients are either very large or very different. In that case, this method becomes a little bit less useful because you'll be multiplying by big values and then it will become more complex. To deal with those questions, we will look at the third method. So let's look at the final method, which is the cross multiplication method. Now the cross multiplication method is a formulaic method in which, ignoring our standard equation for now that we've been using, let's go back to the case where I have a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. Cross multiplication method is simply a case where you make 3 fractions and make them equal to each other. And the fractions are x divided by b1c2 minus b2c1. It will be equal to y divided by c1a2 minus c2a1 and will be equal to 1 upon a1b2 minus a2b1. This is known as a cyclic formula. Remember your numerators, x, y and 1. This is fairly easy to remember, x, y and 1 for constants. In the denominator, when I have x, forget about x. Left with b1c1, b2c2. b1c2 minus b2c1. Move to y, forget about y. To the right of y I have c, c1a2 minus c2a1. Move to the side, I have no variable, so just a constant. Forgetting about that. If I move to the right, equation finishes, loop back around, a1 comes, a1b2 minus a2b1. So the purpose behind this method is this fraction will just be numbers. So we will set our first fraction equal to this, our second fraction equal to this, and by cross multiplying, we will solve. So let's apply it over here. First of all, if you notice, my constant terms should be on this side. So we'll just quickly rewrite our equations and bring our constants to this side. So we get 3x plus 2y minus 6 equal to 0 and 2x minus y minus 5 equal to 0. Our fractions are going to be x upon b1c2 2 times minus 5 minus b2c1 minus 1 times minus 6. It's going to be equal to y upon c1a2 minus 6 into 2 minus c2a1 minus 5 into 3. And they are each going to be equal to 1 upon a1b2 minus a2b1, 2 into 2. So these are our 3 fractions. As I said, we will equate this fraction to this one, this fraction to this one, and separately get the values for x and y. So these were our fractions. I've just moved them a little bit so that we have a bit more space to work. Now, this will become x upon minus 10 minus, now minus 1 into minus 6 will become plus 6. So minus 10 minus 6 minus 16 equal to 1 upon minus 3 minus 4, 1 upon minus 7, which results in x is equal to 16 upon 7, because if you look at it, it will become minus 16 upon minus 7, which is 16 upon 7. This will become y upon minus 12 minus minus 15. So it will become plus 15. So minus 12 plus 15 is plus 3. And it's going to be equal to, this is just the same fraction, 1 upon negative 7, which will give us y is equal to minus 3 upon 7, because it's a positive number upon a negative number, so the fraction is negative. As you can see, the answer is still the same as it should be. The solution is a single solution. This method is not particularly useful for simple equations like this. It is useful for equations with big coefficients or in situations where you might have non-numerical coefficients. That is where cross multiplication method is particularly useful.